Hello everybody, Adam with FANUC here. Today we're going to talk a little bit about the skip instruction, do a quick little tips and tricks on how to use that functionality. Let's dive right in here. So I've set up a little work cell here, nice FANUC R2000, vacuum gripper, and let's say that you have some unknown stack or array of parts. The skip instruction can be used for a lot of things, but it's normally used for finding a part either in a vertical or horizontal plane. Most people use it for detecting slip sheets in a stack, things like that. Today we're going to let the robot find the top of a stack of boxes in this virtual world. So it's going to be pretty simple what we do. It's going to be some basic programming motion that you're already used to with little extra logic put in there for detecting external inputs. So let's start off the bat. We really only need a few positions for this program. We're going to give the robot a place to start with a home position. We'll have one for a start search, which will be above the highest potential point for an object. We'll also have a bottom search where there should be no more objects. And we're also going to create a point called found position. So let's go through and get these set up real quick. For a home position, where the robot is now is totally fine, so I'm going to shift record and teach that. For a start search position, I'm going to move this robot to be slightly above where the highest point of a box should be. So in this situation, I'm going to say, well, there will never be more than 4 imaginary boxes in my imaginary world. So I'm going to start the robot searching here and have it come on down to try and find a box. So let's shift record this. Now for the bottom of the search, that'll be a location that you hope to never find. You're going to teach a point here that hopefully you never ever even get to, but you need to teach it anyway. So let me move the teach pennant out of our screen. Let's get rid of a couple of these boxes. Visibility. Go invisible. All right, we have no more boxes. I'm going to take this robot and I'm just going to bring him all the way down to the bottom of my bin. Down here. So obviously, if you're in a production setting and the robot gets to the bottom of the bin, he's out of parts. You have to decide how you're going to deal with that and recover from that. We'll talk about that in a minute. But we need to teach a position where the robot is heading, the beginning and the end of this search. All right, so I'm going to go ahead and shift record that. Very good. Get the robot back out of the box. The other thing I'm going to do is for my found position, for right now, I'm just going to open up the properties and I'm going to zero everything out. I don't want any data in there. Hit done. I want the position to not be an asterisk, but I really don't want anything in there. So for now, again, it's just all zeros. So those are the only things we're going to use for this program. Let me go ahead and throw some boxes back into this work cell here. All right, perfect. So now we've got some boxes to chase. Okay, let's go ahead and write a program. Let's make a program. We'll call it search. Edit. I'm also going to split screen here. Just so we can have some other stuff available when the time comes. I like to always throw in a handful of lines of code just so I have something to work with. In this case, I'm going to go ahead and set up a general override to maintain a speed of maybe around 30%, just something to keep this thing moving along but not too fast. All right. So let's say, all right, Mr. Robot, the first thing I want you to do is start at the home position. So we're going to start at home. Sounds good. Next, we're going to move to to that second position, which is our start search. Let's get there quickly. No time to waste in production. But once the robot's there, let's start talking about skip. In our instructions, you'll see a skip menu. The skip menu has several ways to trigger a skip condition. It can be when an input equals something, when an input does not equal something, or if we're talking analog, it could be less than, equal to, greater than or equal to. All different conditions for what's going to make that robot stop trying to hunt for a box. So let's, for example, if you had a vacuum sensor, okay, in line with that vacuum cup, you could be moving down until the vacuum sensor's made. If the vacuum sensor's made, that means you have a part. All right, go get to work. It could be a distance sensor, a prox, something that says, yep, I found the part. It could be a touch probe. It could be any multitude of things. Here and today, it's going to be a virtual signal because I'm in RoboGuide. I'm in a virtual world. So I'm just going to say, hey, digital input 1, if that comes on, the robot found something. So over here, let's go ahead and let's take digital input 1. Let's give it a name. Let's call it, vacuum sensor, because that's something that would be realistic for this. As soon as I comment that it's a vacuum sensor, it dumps it into my code, which is nice. Then what I'm going to do is, for the sake of this video, I'm going to simulate. I'm going to set that as simulated. So normally it'd be physically wired or come from a PLC or something. I'm going to simulate it, and I'm just going to trigger that vacuum sensor by myself. But nonetheless, let's move on. So we know where we start our search. We've now told the robot what to look for. We are looking for a vacuum sensor. Now what do? Now we get to work. Let's say I want to move linearly toward the bottom of that stack that we hope we never get to, the bottom of the search. This number now becomes pretty important. The faster you move this robot, obviously the less reaction time you're going to have when it sees that sensor come on. So if you're really hauling the mail 2,000 millimeters per second, you'll probably have destroyed the box by the time that vacuum sensor comes on and anything under the box. So we like to keep that something moderate, something, and it's to be determined on your end. You can fine tune it. For now, I'm just going to go 250 millimeters per second, and say, hey, slowly move down until you find a box. Now here's the secret sauce right here. There's always the magic trick here. All we have to do is use this option, skip label PR. So now what I've done is I've told it, okay, robot, start here, pay attention to DI1, head toward PR3, but we've got these extra pieces of code here. For right now, I'm going to put in just any label number, doesn't matter. Label 1 through 1,000, pick your favorite label, doesn't matter. PR, I'm going to say PR4. So as I'm building this, what's going to happen is if the robot finds a box with that vacuum sensor, it's going to skip going to PR3. Say that again. It's on its way to PR3, but if that condition comes true, it'll quit going to PR3. It'll take an L pause. If you've not used that before, it's linear position. It grabs the position of the robot. It's going to grab the current position of the robot in Cartesian coordinates, X, Y, Z, yaw, pitch, roll. It's going to dump it into PR4. Do you want to use that information? You don't have to, but it's up to you. You're going to have it. That way, if you know the height or the thickness of your boxes, maybe you only need to skip to find the first one. Once you know where the first one is, now you can use offset math to get the other three. That way you're not always doing this real slow search. Just use the slow search to find the first one. L pause tells you where the first one is. then some simple math can tell you where the others are. But at the core, this is what we're doing: is we're going to stop going toward PR3 and record our position if this happens true. So let's finish writing the code before we talk about this label 10 guy. Let's finish writing what happens in a good scenario where we found that box. Okay, so if I found that box, maybe my next thing would be, turn on an output. In some case, maybe your vacuum. In this case, maybe the vacuum's already on. I don't know, or maybe we used a prox sensor to find the box, and now we turn the vacuum on. It's up to you. This is just for fun. I'm going to toss in a wait statement just so we can definitively see the robot pause when it hits the box. Otherwise, when it hits the box, it's just going to take off and get out of there. And what do we want to do after we find a box? We want to go back. Let's do a PR. Let's go back toward the start of our search. We'll go quickly, go straight back up again, and then maybe just go home. Okay. Perfect. So I'm gonna add in a few more lines. Kind of ran out of room here to write my logic. Right here, I'm going to use another instruction. It's under the call area, but what I'm actually going to do is I'm just going to end the program. You'll notice down at the bottom of every program is a built-in natural end, but in this case, this program has two different outcomes. It has one where we find a box and we're happy, and one where we don't find a box and we have a problem. So this one program is going to have two different ends. If we found the box, we turn on our output, we go back home, life is good. What happens if we don't find the box? Here's where that label 10 comes into play. Right here. I'm even going to name it. I'm going to say no box. So now if you look back at this line 9 of code, we're headed toward PR3, hoping we don't get there, hoping we can skip out of that motion. But if we do get to PR3, the robot knows, well, all of this code is now junk, and we need to go to label 10 instead. So instead of doing our normal production routine, when it says, well, I made it to PR3, better go to 10, it's going to jump from here and go all the way down to this label and then do whatever you have here. This is dealer's choice. This could be calling a subroutine. This could be going to a maintenance position. Heck, in this case, it could be throwing a user alarm. An alarm that notifies people, hey, I don't have any boxes. Throw a fault. If you've never used user alarms before, it allows you to build your own alarms. Let me show you here in our browser page. The robot tools page, there's a comment tool. We can jump in the comment tool. This is where you can name your registers, your PRs, your strings, but you can also set up user alarms. You can see I've already been playing around in here, but I want to set up user alarm 1 that says no box was found, something like that. So now in our program, if we ever get down to that point, the teach pendant will notify the operator that no box was found. So let's go ahead and let's play with this a little bit, and let's just see where we're at. The first thing I'll do is I'll go ahead and I'm going to manually be the vacuum sensor, and I'm going to trigger that robot, and when he starts getting toward that top of the box, I'm going to tell it, hey, you found the top of the box by simulating the I/O. When that happens, you should see robot output 1 come on, the robot will pause, and he goes home all happy. So let's try this. Play. All right. So robot is slowly searching. Hey, you found a box. Up and home it went. So you can see in this case, RO1 is on, which means we executed that line of code. You saw the robot physically pause. You saw it go back up to the search and go back home. So let me turn that off and turn that off. Let's go ahead and pretend that there are no boxes, right? So let me highlight these guys and say, yep, no boxes. So now when we run this robot, run, you see it's going through its nice slow search program. Because this is not coming on, it's still trying to get to PR3. So it's hunting, it's hunting, it's hunting. And let's see what happens when we get to label 10. Boom. So we've issued a user alarm. Right on the teach pendant, we have a user alarm that says no box was found. So that's nice. It guides your operators to let you know what's going on. And the robot pauses. In this case, it pauses. Obviously, you could set this up to be something else where maybe it sets a flag or an output and then goes home, but it's doing what we told it to do in this case. So for this example, robot did exactly what we needed it to do. When there's no boxes, it skipped the good logic and went down to label 10 and threw an alarm. When it did have a box and did make a sensor, it just executed this code as it normally would. One more thing I want to show you is where it puts the data for those found positions. Like I said, whether you use it or not, it's going to be writing to those positions. So let's go ahead and run this one more time. I'll be the vacuum sensor. Okay. So let's go take a look at PR4 in our data. Remember, we had it at all zeros. If we open it up, it's no longer all zeros. It has the X, Y, Z yaw pitch roll coordinates. Right now, we really only care about X, Y, Z, especially the Z. But we know now where in space the robot was when it found that top box. So if you know that top box is at 134 millimeters, relative to world frame, which is relative to J2. So it was 134 millimeters above the robot's belly button. Now we know where the rest of all these boxes are by doing some simple math. So you can feel free to use that as much or as little as you need. If you have any questions, please put them in the comments section. Let me know what you think. Other questions or topics you'd like to see covered, you can always contact us at 888 FANUC US, and always remember to have fun coding.